afternoon one and all. Myself, Professor P A Gaikwad, Assistant Professor, Department of Chemistry, MPSC College Panvel. I am teaching the important article of TYBSc, that is Metallocene. So this article is included in unit organometallic compound. So that Metallocene is important organometallic compound. So we know the definition of organometallic compound. The organometallic compound in which a metal atom is in between two planar polyhaptoligand are generally called as Metallocene. Such compound are also called as a sandwich compound. The most popular and well-studied metallocene are the complexes of transition metal with cyclopentadienyl group as a ligand. So this is the important type of organometallic compound, metallocene. So that metallocene is formed by transition metal. When that transition metal is combined with cyclopentadienyl group, and that cyclopentadienyl group is one of the important ligand. So this cyclopentadienyl ligand, when added with transition element, it can produce a compound, and that compound is nothing but metallocene. Then in most of the metallocene, cyclopentadienyl group is cyclopentadienyl means C5H5 is a pentahaptoligand. It is a 5 electron donor ligand. The first metallocene reported in 1951 was ferrocene, that is C5H5 twice Fe. In ferrocene molecule, Fe is sandwiched between two planar ring of C5H5. So in that ferrocene, Fe is the metal, that is iron, and that iron is present in between two planar C5H5 ring. So that C5H5 is a cyclopentadienyl ligand, and that iron is sandwiched between these two cyclopentadienyl group C5H5. Metallocene can be represented with general formula, that is Cp2m or mCp twice. So here m is nothing but metal, and Cp represent cyclopentadienyl group, and it is a 5 electron donor. Some example of metallocene are cobaltocene, that is formula of cobaltocene is C5H5 twice CO. So here cobalt is present in between two cyclopentadienyl group, that is C5H5 ligand. Then nickelocene, C5H5 twice Ni, etc. So these are the important example of metallocene, that is cobaltocene, nickelocene. Then after the discovery of ferrocene, cyclopentadienyl ligand plays a very important role in the development of organometallic compound. So here this ferrocene is a very important example of that metallocene. So the structure of ferrocene can be shown here, that is F C5H5 twice, or its IUPAC name is bis pentacyclopentadienyl iron. So this pentahaptocyclopentadiene is a organic type of ligand, and therefore it is placed in a bracket. There are the number of these ligand is 2, and because of this number 2, we can use here prefix bis. Then synthesis of that ferrocene. So ferrocene was the first metallocene we discovered accidentally by two different groups of worker. The formation of ferrocene was serendipitous making fortunate discovery accidentally. So first method of that preparation of ferrocene is by the oxidation of cyclopentadienyl Grignard reagent. So this ferrocene was prepared by the oxidation of cyclopentadienyl Grignard reagent. So first time it is prepared by Calle and Poisson in 1981. Synthesize fulvolence by oxidation of cyclopentadienyl group Grignard reagent with ferric chloride. But surprisingly, instead of fulvolence, unexpected product which was orange color substance obtained. This substance was stable and could be sublimated in air without decomposition. This new compound was later identified and named as ferrocene. One of the methods to synthesize ferrocene is the oxidation of cyclopentadienyl Grignard reagent with ApCl3. The ferric ion, that is Ap3 plus, used for oxidation is first reduced to ferrous ion by Ap plus 2 by cyclopentadienyl Grignard reagent, and then Ap2 plus react with Grignard reagent to form ferrocene. So reaction is 2C5H5 MgBr plus 2 ApCl3. So it produces here 2 ApCl2 plus C5H5 C5H5 plus MgCl2 MgBr2. Then 2C5H5 MgBr plus ApCl2. It produces C5H5 twice Ap plus MgCl2 plus MgBr2. So here these C5H5 twice Ap means ferrocene is prepared by using that first method, oxidation of cyclopentadienyl Grignard reagent. So in that reaction, Ap3 plus is first reduced to Ap2 plus, and then this Ap is combined with cyclopentadienyl group, and it can produce ApC5H5 twice. Then second method is direct reaction between iron and cyclopentadiene. So here ferrocene was independently discovered during the direct reaction, reduce iron and cyclopentadienyl at 575 Kelvin temperature. In this method, base-like amines are used as they help the removal of acidic hydrogen of cyclopentadiene. So ferrocene is obtained at a relatively lower temperature. The mechanism of the reaction are as follows: Ap plus 2R3NH plus Cl minus. So it can produce ApCl2 plus 2R3N plus H2. Then ApCl2 is combined with 2C5H6 plus 2R3N. So it produces ApC5H5 twice plus 2R3NH plus Cl minus. So here that ApC5H5 twice is prepared by using that method, that is a direct reaction between iron and cyclopentadienyl group. So by using amines in that reaction, that amines are used or help to removal of acidic hydrogen. So the net reaction is Ap plus 2C5H6. So it can produce ApC5H5 twice plus H2. So we see chemical properties of that ferrocene. So first reaction is, first property is acylation reaction. So ferrocene react with acidic anhydride and form mono and diacetyl derivative under suitable condition of Friedel-Crafts reaction. So in that acylation reaction, ferrocene react with acidic anhydride and it form mono and diacetyl derivative under suitable condition by Friedel-Crafts reaction. Monoacetyl derivative is formed in presence of H3PO4, that is phosphoric acid. So the reaction is Ap C5H5 twice plus CH3CO twice O is acetic anhydride. So it can produce CH3CO C5H4. Here one hydrogen is replaced and there a P group is attached, a P C5H5 plus CH3COOH. So this is called as monoacetyl derivative. Then diacetyl derivative is obtained in presence of anhydrous AlCl3 catalyst. So the reaction is CH3CO C5H4 Ap C5H5 plus CH3CO twice O. So it can produce Ap C5H4CO CH3 twice plus CH3COOH. So that this is the diacetyl derivative. So here Ap is attached to C5H4CO CH3 twice. So there are two acetyl group and therefore this is called as a diacetyl derivative. Then third reaction is next reaction is sulfonation reaction. Ferrocene undergo sulfonation reaction with concentrated H2SO4 and form monosubstituted derivative. So here C5H5 Ap C5H5 plus H2SO4. So it produces C5H4SO3H Ap C5H5 plus H2O. Then third reaction is alkylation reaction. Ferrocene react when treated with ethylene at 30 to 40 atmospheric pressure and about 400 Kelvin temperature in presence of AlCl3 as a catalyst. It forms ethyl derivative. So the reaction is C5H5 twice Ap plus CH2 double bond CH2 ethylene. So it can produce C5H5 Ap C5H4 CH2 CH3. So this is the ethyl derivative and therefore that reaction is called as alkylation reaction. Then fourth reaction is oxidation reaction. So here ferrocene is easily oxidized by aqueous Ag plus or dilute nitric acid to a stable paramagnetic blue ferrocenium ion, that is C5H5 twice Ap plus. So the reaction is C5H5 twice Ap. It produces C5H5 Ap plus. This oxidation reaction is reversible. Electron is removed. So like that manner, these ferrocene undergo different types of reaction. That is acylation reaction, alkylation reaction, sulfonation reaction, and oxidation reaction. So we are studied here these important properties of ferrocene. So we stop here. Thank you.